If you've ever stood next to an air conditioner on a hot day, it can feel almost magical. Warm air goes in, cold air comes out. But here's something surprising. Air conditioners don't actually create cold air. Instead, they do something much simpler and much stranger. They move heat from one place to another. Understanding how this works reveals one of the most clever engineering ideas used in everyday life. Let's start with a simple question. Why does air feel cold in the first place? Cold isn't really something that exists on its own. What we call cold is simply the absence of heat. Heat is energy stored in the motion of molecules. The faster molecules move, the hotter something feels. The slower they move, the cooler it feels. So when an air conditioner cools a room, it isn't creating cold. It's removing heat energy from the air inside your house. The question is, how? The secret lies in a special chemical called a refrigerant. Refrigerants have a useful property. They can easily change from a liquid into a gas and back again. And when they change state, they absorb or release heat. This simple idea is the foundation of air conditioning. Inside your air conditioner is a set of metal coils called the evaporator coil. These coils contain cold liquid refrigerant. As warm air from your house passes over the coils, something important happens. The refrigerant begins to evaporate, turning from a liquid into a gas. When it does this, it absorbs heat from the surrounding air. That heat energy moves into the refrigerant. Meanwhile, the air that lost its heat becomes cooler. That cooled air is then blown back into your home through the vents. But now the refrigerant is carrying all the heat that was removed from your house. So where does that heat go? This is where the outdoor unit comes in. The refrigerant gas travels outside to a component called the compressor. The compressor squeezes the gas tightly, raising both its pressure and its temperature. Now, the refrigerant is extremely hot. In fact, it's usually much hotter than the outdoor air. This allows the heat to move outward. The hot refrigerant gas then passes through another set of coils called the condenser coils. These coils are located in the outdoor unit, the part of the air conditioner you often see beside houses. A fan blows outside air across the coils. As this happens, the refrigerant releases its heat into the outdoor air. When it loses enough heat, the refrigerant turns back into a liquid. In other words, the heat that was inside your house has now been dumped outside. But the cycle isn't finished yet. Before the refrigerant returns indoors, it passes through a small device called an expansion valve. This valve suddenly reduces the pressure of the liquid refrigerant. When the pressure drops, the refrigerant becomes very cold again. Now it's ready to return to the evaporator coil and repeat the entire process. Warm air passes over the coil. Heat moves into the refrigerant. Cool air flows back into the house, and the captured heat gets carried outside. This cycle repeats continuously while the air conditioner is running. Over and over, the system moves heat from inside your home to the outside environment. That's why air conditioners always have two parts: an indoor system that absorbs heat and an outdoor system that releases it. Without the outdoor unit, the heat would have nowhere to go. Interestingly, this exact same principle is used in other appliances. Refrigerators and freezers operate using nearly identical technology. Instead of cooling an entire house, they simply move heat from inside the fridge to the room around it. If you've ever noticed warm air blowing from the back of a refrigerator, that's the heat being removed from inside. Air conditioning is essentially the same process on a larger scale. There's also an important reason air conditioners are designed this way. Moving heat is far more efficient than trying to generate cold directly. If engineers attempted to create cold, the system would require far more energy. By simply transferring heat from one place to another, air conditioners can cool large spaces using surprisingly little electricity. That efficiency is one of the reasons air conditioning became widespread during the 20th century. Today, it allows millions of buildings around the world to remain comfortable, even in extremely hot climates. So the next time cool air flows from a vent on a hot summer day, remember what's really happening. Your air conditioner isn't creating cold air at all. It's quietly capturing heat from inside your home, carrying it through a hidden cycle of evaporation, compression, and condensation and releasing that heat outside. It's less like a machine that makes cold and more like a pump that moves heat away from you. This has been Questions Answered. If there's another everyday technology or mystery you'd like to see explained, let us know in the comments. And if you enjoy learning how the ordinary things around us really work, consider subscribing. Thanks for watching.